Hello, everybody out in Facebook world and also in our Zoom. I guess we could start letting people in so they can get on the action. I'm sharing this to my page so all my friends can be jealous they're not here. Today, we're going to talk about the engineers. So Greg Kirchner is here from Intertech, and then we'll also have a gentleman by the name of Brian Lynch come in from Bottle One to talk specifically about what happens in that process. But like everything else, um, we have to start with our legal disclaimer because I'm an attorney and I like legal stuff. As a reminder, we are subject to the SEC regulations for this crowdfunding. We will not be taking money indirectly. Our crowdfunding portal partner is WeFunder, and all the investment advice, et cetera, that you're receiving is also posted in WeFunder, our WeFunder platform, and all investments will go through there. We are very, very close to our public offering. We have kind of crossed some T's and dot some I's. We had to move it back from May 1st to May 7th. It might get actually pushed back into the middle of next week for marketing purposes. We have some wonderful film coming out. It's not video. The videographer is for people who do use your phone. This is a film. We have a short film coming out with a series of teasers coming up, done by Pineapple Cuts Films. They did a fantastic job. That'll be launched next week. We got a bunch of podcasts, advertisements going out. So next week when we launch, it'll be a big, big story. We're very excited. So our next investor call probably won't be for a few weeks. It'll be, May, I guess, throughout some dates, 26 is likely to be our next investor call because we'll be doing so much marketing. And then you'll be able to tell the world about StarWalker and this investment opportunity. So, but time is winding down and it's getting very exciting to actually start to launch publicly. All of these videos are being recorded. So if you have time, you can go back and watch the prior episodes, but they're all being recorded. They're in the link invest.starwalkerindustries.com. But again, until our 4MC is filed, we're still in what we call test the waters. So with that being said, Shark, if you want to go ahead and pull up our guest speaker, Greg Kirchner from Intertech. We'll highlight him. Greg, are you there? We'll ask him to unmute.
I did.
Yes, I am.
Okay,
Hey,
Greg.
good morning, everybody. Today, as David already said, we have Greg Kirchner, who is our chief engineer. Greg is with Intertech Limited, and Greg has done so many big projects throughout the continental United States in building plants from the grow up and refitting the right machinery in different plants. So he's our chief engineer, and he's really going to talk to us today about the bottled water process and just how bottled water is put together from an engineering standpoint. So Greg, the floor is all yours. Please go ahead.
Thanks, Shar. I also have Bruce Clevenger in the office with me. Bruce has been doing this for, I guess, 30 years. And as is our primary VP of execution, and takes plants from the ground up all the way through the implementation, startup, and execution. So including training and operations. So we're very excited to be part of this team. As Shara said, we've installed literally hundreds of lines, particularly in the water market, which is the dominant market in the beverage industry over the last 5 to 10 years. So very excited. This is a traditional bottled water plant utilizing reverse osmosis and ultrafiltration techniques to take water that you would get in through the city water system and basically remove all the chemicals and organics and things that you don't want to have in your system, and clean it all out, and then can inject some minerals that are good for you and healthy and add to your body chemistry. So
Greg, I don't know if you have a camera, but we can't see you. There you go. That's your, there's your smiling face. So you said a lot of words, chemical, plants, things like that. I'm just going to interview you here a second. We're going to break down a little bit about how you even got into this, because you're from Georgia Tech. You're a rambling wreck from Georgia Tech. You're an engineer. How did you even get into this business at all?
So Bruce is over here as well. Bruce. And Bruce and I both went to Georgia Tech. I was class of 1939. No, it wasn't 39. Just feels that way. It just feels.
You're around for the first pandemic, huh?
Exactly. So no, I got into this from an engineering perspective. We've done a lot of work throughout the world for a lot of people who have been making plastic containers since the 70s, 80s. Started getting into it from a heat transfer perspective because of my mechanical engineering background. Bruce is an industrial engineering background, so has a lot of experience in the product flow, product warehousing, manufacturing aspects of a facility. So Bruce and I were able to come together. I guess that we started working together probably in the early 90s. And then have been had the opportunity to work together closely in building plants since then. So
that sounds like fun. Greg, I have in my hand a mix of 50-50 virgin and post-consumer resin, right? This is a blend. I've been talking to people about how we turn this into this, a preform. Can you go over just some of the equipment it takes to take something like this? First of all, where can we get something like this resin from? And what kind of equipment does it take to take this resin and make it into a preform? And we'll talk about blowing it later, but can you tell us a little bit about that?
Sure, I'm going to let Bruce explain it because Bruce is really good at this. In fact, he just installed probably, it takes a machine called an injection molding machine. And we just installed 3 in Ohio, or 2 in Ohio recently and 3 in North Carolina. And have one going into a facility in Las Vegas and another one in Utah. So Bruce has installed literally hundreds of these. And so I'm going to let him take this one and I'll take the next question.
So basically, David had some, he's got a bag of pellets there. All PET resin basically starts as pellets. 2 terminologies there, it's virgin resin, and he's also talking about post-consumer resin, but all that resin has to be dried. PET is very, attracts water, so it has to be dried to a very low dew point. Takes about 4 hours to dry it. Then it's injected, molded into a preform like David's got there. The molds can range anywhere from 24 cavities, making 24 at a time, to large water machines that produce 144 at a time. So anywhere from 6 seconds to 20 seconds. Preforms are quite hot when they come out of the machine. They're held on by a robotic extraction system. Basically, they're cooled with the robot. Then they're put in Gaylords. So, but the process is pretty capital intensive, but yeah, and most of the equipment we put in is from Husky. They're manufactured up in Canada. So.
Yeah, when we talk about PET, what does that stand for actually?
Polyethylene tetrasilate or something like that.
Tetraphalate, yeah, phalate.
Yeah,
So
yeah,
that. It's a long word. That's why we always just talk about.
I can tell you the difference between PET and polyethylene. Crude oil is the base product for PET, and natural gas is the base for polyethylene.
One of the things that StarWalker is looking to do is really increase our post-consumer PET or resin. Let's talk about how we take something like, PET and grind it down and turn it into this and make it post-consumer resin, because we've been talking about how if we really want to do this, we have to keep all of our bottles together in order to get some good post-consumer recycling. Can you talk a little bit about the differences between virgin and post-consumer recycling?
Sure. So one thing I did want to mention on the injection side, because of the process of melting the plastic and keeping it dry that Bruce talked about, that operation tends very much so towards a 24-hour operation. And we'll talk about that a little bit later when we talk about blow molding, because the blow molding can be more of a just-in-time process, which is advantageous in the production and filling of packaging. But on the preform side, that tends to be a 24-hour operation. So the post-consumer recycled material is exactly what that says. It means that the consumer has handled it, and now it's coming back into the production stream. It relies on basically you and me and everybody else to take a bottle such as this after you drink it and put it back into the recycle stream so that it can be cleaned, washed, ground up, put back into pellets in many applications, and then mixed in with virgin material, much like what David is showing. So the nice part about PET is that when you put it through the recycle stream, you can reprocess it, and basically it becomes just like virgin, and you can do it over and over and over and over again. So the same bottle that you drink today can be ground up, put into another bottle, tomorrow, and then that bottle can be ground up and it can be put in another bottle on Friday. So that's the nice part about PET as opposed to other resins like your milk container, which is high density. That material can be recycled, and we would want to encourage people to recycle, but it typically is downgraded. It would not be put back into a bottle. It would be used as carpet backing or park benches or something like that. So.
Yeah, that's good. I think that one of the things we've talked about before is, first of all, resin, PET, and plastic are all the same thing. Okay, so I know we've used those words interchangeably, but they're essentially the same thing. But talk about how much engineering and energy it takes to try to make this turn into this. I mean, what kind of equipment are we talked about? You talked about an injection machine, but what kind of other utilities might go into creating that injection machine to kick out those preforms?
Yeah, so there's a lot of engineering that goes into it. You have to have that bag of resin pellets has to be transferred, typically either from a truck delivery system or rail car. It's usually stored in a big silo that looks like a corn silo if you're driving up through the Midwest. So it comes out of the silo. You have these pumps that pump it over into the drying system. Since you have to dry it, means you have to heat it. You heat it up to a pretty high temperature, and then of course you have to melt it. So after you melt it and put it into your mold to make it look and shape it like the preform that Dave is holding, then that means that you have to cool it in order to take it out of the mold. So that means you need cold water. So there's a whole system that goes into play of providing the cold water to make sure that you can cool it down. As Bruce talked about, the cycle times vary. So depending upon how much weight is in that preform, and it's all measured by grams. Typical preform for a CSD bottle like this might be 15 grams. Those that don't know their metric system, there's 454 grams in a pound. So basically 30 of these bottles would equal a pound. So ours bottles weigh somewhere around 60 to 70 grams. So that means it's got a thicker wall, which means it takes longer time to cool. And you get a higher cycle time. So there's a lot of things from an engineering perspective that go into play in developing and designing the cooling circuit so that you can get the mold out of the mold quicker and put new plastic back into the mold sooner. So the more you can do that, the more plastic you can produce in an hour, and that reduces all the structural costs.
So how, just to break it down, how many of these with your high-tech machines, how many of these can a highly efficient machine produce? And let's say, I don't know what time element you want to use, an hour, a day, a year.
Use them all. So that tool, because of the handle, has a limitation on how much space we can put between molds. But so we can get 48, the biggest cavitation, the most we can make in one tool is 48 pieces. That cycle time is roughly 20 seconds. So that means for every minute you make 48 times 3, right? So 96 plus 48 is what, 132.
Yeah,
Do my math.
142, yeah.
Yeah. So you can make those every minute, and roughly in a year, you can make about 70 million units.
Okay, great. Now, we will not be making preforms at our facility. We will have someone make them and ship them into us, because you mentioned you don't have to take it from preform and put it right into the blow mold machine, right? So they just kind of collect. And so there's people out there who make preforms in different sizes, right?
That's correct. And so, yeah, and like I said, the preform operation tends to be a 24-hour operation. The filling operation tends to be anywhere from, 1 shift, 2 shifts, 5 days, 7 days a week, whatever. So it's usually not very advantageous for people to make their preforms unless you get into that 50 million units type numbers.
Yeah, I think that ordering the preforms for the outside, you mentioned a very important part. When you make these preforms, your equipment has to stay on for 24 hours, right? And explain about that in terms of, with a blow motor, when you fill it and blow it out, we talk about that later, you can kind of turn it off and on. But if you make these preforms, your equipment has to run 24 hours no matter what. Why is that?
Well, once you get the plastic flowing, and you're trying to melt the plastic beads that you held up, and you're trying to get it to flow down through a tube, and so once you get that flowing, you don't want to stop it. Otherwise you get a lot of cleaning that you have to do. Once that plastic starts to solidify, then you have to clean everything out, and then you have to start the whole drying process all over again. And as Bruce said, it's about a 4-hour process. So it takes you, usually a shift to clean up, a shift to get started. So there's just a lot of wasted time and energy and efficiencies. So what you want to try to do is just keep that plastic flowing once you get it hot and melted and starts flowing into its injection tool.
That's right. And we're going to, in our plant, we're not going to do that. We're going to have someone else make these preforms and ship them in. And they ship in the quantity, I believe it's a tote. So how many comes into a box of preforms? How much is in a tote?
Oh, that might be a question Brian can help with, since he'll be one of the sources of your preforms.
Yeah, so you're going to see about 2,400 in a single 48 by 40 tote. It's about 50 inches high. So essentially 2,400 bottles in one little tote. So it's quite remarkable.
It is. And I want to welcome Brian to our program. He's with Bottle One. He's going to talk about the blow molding process in a minute. Greg and Bruce here kind of giving us a little recap on how injection machines work and how we get to this point in taking this resin and making it here. Remember that resin, if it's virgin, all comes from a natural resource. So the more post-consumer resin we can include in this bag, the better we off as humans, so that we can create that closed loop system. So that's why we're trying to get our bottles back so we can get more post-consumer resin. We will bundle our bottles and ship them off to someone who will do what Greg says, melt them down, put them in the pellets. We're just one piece in a huge closed loop system, but we're going to do our part. I know that both Greg and Bruce has to go to other meetings. They're superstar engineers, international players. They do a lot of things. They don't have time for our little micro plan over here. But anyway, if you have questions for Greg and Bruce, you can please put them in the chat and we can follow up with them at all. I mean, this is high level engineering talk. We're not going to really get into any details, but Greg kind of showed us how we get to this. And now we're going to take Brian to teach us how we go from this to this to this, right, in the actual water. So I'd like to welcome Brian from Bottle One Brian will be the one selling us, if you will, these preforms. Brian, why don't you go ahead and tell me what does it take for a guy like me to receive one of these and make it just this? Forget about filling it for a minute. How do we go from here to here?
Well, so this is I'm sure as Greg explained, I apologize for my little tardiness here. It's a two-step process, right? You have the injection molding component, which is to make the preform. And then we have what's called the stretch blow molding process. So essentially, we have a machine that will take that preform and it will, we will dump all those preforms, onto a conveyor, and it will index them, and we'll feed them one at a time into an oven. The particular machine that you're going to be utilizing is a rotary machine. So it's capable of running, upwards of 9,000 bottles an hour, depending upon the size of the bottles, of course. Half gallon smaller, you get more numbers. A gallon, which will be larger than your 96 ounce, you'll get less. So depending upon the size of the bottle, you'll do about 7,000 bottles, per hour. And, this goes through, it gets indexed down and goes through an oven, and it's a rotary oven. So it travels in a circular path, and the preform is rotating. It's rotating while it is going through that oven. So it's getting heated. And so you got to worry about your lamps. So your lamps are coming down here and around the handle. And so it's designed to fit for the preform, and it's going through the oven and it's traveling around the circular path. And so we're putting the heat where we need it to be. So below the handle it gets heated and then stretched, and on top it kind of gets pulled out. So the shoulder is kind of coming out, and this is kind of getting stretched to the bottom. And so after it comes out of the oven, it goes into a rotary molding system. There's 6 molds in the machine, and it's rotating, and they're making 6 at a time. So after the mold's heated up, the preform's heated up, goes into the mold, and it does a circular loop while that gets blown and then exits the machine.
Well, a lot of us kids grew up in the 80s, only know manufacturing from watching Laverne and Shirley. And we have this tendency to think that these bottles are kind of coming down, getting blown, and moving along. But you just said a lot. But how long does that process take before it goes into the machine like this and comes out like this? It's not something that I can see.
Well, again, you're making 7,000 an hour, so you can see that it's moving very rapidly around that whole loop, seconds essentially, where it is just transferring. And it's getting, essentially you're taking this and you're blowing it out like a balloon would get filled, and it happens very rapidly. We can show some videos maybe in a future call, David.
Yeah, we'll have some videos posted up. We're gonna have videos of our plant doing it. What are you talking about?
There you go.
We're gonna show our videos of us doing it. But when I get this bottle, right? So I buy my blow mold machine that makes me 7,000 to 9,000 of these units per hour, and now I have the bottle. How does the bottle go to the water? Can you talk a little bit about the process for how do you blow something and then fill it? Do you blow it first and fill it, or are you doing both at the same time? Can we talk a little bit about that?
That's a great question. So you actually we'll start off your production line with that preform dumper. You'll blow the bottle, and then it gets conveyed, right? It comes out of the blow molder on a conveyor, a flat top conveyor, and the bottle's sitting on top of it and drying down the plane. And so you have to do a couple different functions, Dave. You have to fill it, you have to cap it, you have to put a label on it. Then you're going to do an overwrap where you're going to package it into a unit of 3. And then you have to palletize it, right? Pallet has got to get built of the whole. So there's a lot in that process, in that production line that you have to manage. The coming out of so the blowing the bottle is just kind of the first step.
Well, let me ask you this: when you blow a bottle like that, and I understand it goes through an oven, the plastic is essentially being stretched. You know, I've burnt plastic before. It doesn't smell very good. What makes it safe from the time it's been blown to the actual time that the water gets put in? Meaning, if I blow this bottle and put water in it, aren't I melting the bottle with the water, or is the water getting affected by the hot
Well,
plastic?
That's a great question. So in the blow molding process, in the molds themselves, we have cooling channels. So the bottle, the preform's getting heated up, goes into the mold where it gets blown out. But in that mold, there's a cooling process that the bottle is going through to solidify. So when it does come out, it's fully formed and ready to go. Great question. So it gets
So it's
cooled
safe.
in the molds.
So it's safe. It's safe to then fill with water and put the cap on.
Correct.
Okay, and so just in general, how Greg mentioned before, injection machines that make the preform can't be turned off and on. But I mentioned that the blow mold machines can be turned off and on. What makes them different between the injection machine that has to stay on and the blow mold machine that can be turned off and on?
So that's another great question. So the blow mold can be turned off and on, and you can match your requirements and needs, the production of the bottles, to what those needs are in terms of a filling capacity. The injection machine or the extrusion machine is a kind of a different process. And what happens is, if the machine were to stop, that plastic would solidify in the mold, in the lines, in the screw and barrel. So that plastic would solidify where it is. And
you're talking about for the preform, to make the preform, you're talking about the plastic to make the preform, it has to stay hot and so that it can keep going.
Correct.
But the machine that after it takes the preform and turns into this, it doesn't have to stay hot. The oven used for this, and is it because the temperatures are different? Why is it that the oven that makes this doesn't have to stay on? You can cut the oven on and off, whereas in making the preform, you cannot cut the oven on and off.
Well, so you've already got a solid part here. So you're just taking that and blowing it out. You're not starting with melted plastic, right? Your plastic on the injection side is melted and it's flowing, and so if it solidifies, then you've got everything's blocked out. So that's why you can't turn it off. But this is already solid. You're just heating it to be able to make it malleable, right? And so it's a little bit different.
So I've been advocating for a long time that plastic is the most efficient and beneficial way to deliver water to humans. Do you agree with that statement, or do you think that there's other ways to deliver water and other manufacturing processes that are just as efficient as plastic?
Oh no, plastic, PET in particular is the be all end all. I've been involved in packaging for 30 years, and this product is the most cost effective product with the most strength and durability that you could possibly want to deliver a finished good. And just as importantly, it's completely circular. I can take a finished bottle, grind it up, and make a new preform out of it. It is the most versatile resin that it is. It's got the strength, the durability, it's got oxygen barriers, it's got a hermetic seal. It won't leak. Your product will last longer because of a hermetic seal, because you got a high precision part, high precision closure, and so it does not leak. Where an HDPE bottle, like a milk jug, that leaks from the plant to your shelf. So, I mean, this is the be all end all for sure. And I've been involved, like I said, over 30 years. I was involved in the conversion from Coke and Pepsi to those low profile plastic crates. They used to be in full depth box. That bottle has the strength and durability needed to be its own transport vehicle. And that's so environmentally, it was such a sound move, and similar to what we're doing here. I mean, it is the best.
Yeah, let's talk about what makes bottle one so special. So you told us about the blow molding process. And if you notice that when you have bottles like this, the preform is obviously like a test tube. It's a small little test tube that gets blown out. And you notice that this has the handle. So can you tell us what's so different about this bottle compared to, I don't know, any other preform bottle that you've seen out there?
So this is again, having been in over 30 years in packaging, this has been a 30-year holy grail for packaging. PET, up until Bottle One's inventions, new to the world technology, was unable to have a handle on a large format package, large format being half gallon and above. So you either had to have an HDPE product like a milk jug, or you had to have use PET, but you had to add a handle, whether it's a bale carrier over the top or a neck, something around the neck ring that you see in some alkaline waters, or molded in like an ocean spray. So there's always this secondary process, which like a carrier, 20% of the time, it was not there when you needed it. So it may or may not work. It was slow, added a lot of cost. We have the invention to add the handle and the integrated handle and part of the manufacturing process with Bottle One. That's the invention. It opens up everything in terms of for improvement, especially the supply chain, eliminated secondary packaging. Shelf life is increased. Water in an HDPE bottle has a much shorter shelf life than one in the Bottle One because of the hermetic seal. PET has 50 times the oxygen barrier properties than HDPE. So it is a much better performing product. Your product will last longer. It's really quite
Let's talk about, we know
significant.
that there's different levels of plastic, and I know I've heard you guys say this term often, HDPE. If I can break it down for our watchers out there, we've talked about this before. Plastic has different properties, 1 through 7. We talked about the recycling and 1 through 7, but high density PE or HDPE, where can I find that plastic mostly? It's a different plastic than PET, but where would I see that plastic a lot?
So HDPE is a number 2. I think you mentioned PET is a number 1, HDPE is a number 2. HDPE can be recycled, but it's not circular. You can't put recycled post-consumer milk jugs back into new milk jugs that are HDPE.
So our milk jugs that we see, the cloudy, thick jugs, those are not PET1. There are HDPE. Those are thicker jugs.
Number 2, correct. And so you can't put recycled content in those bottles. That materials is downcycled. What we say is downcycled. So it goes primarily into like carpet backings and fabric. PET can go circular, so it goes right back into another bottle. It's the most valuable recycled material that there is on the market today. And what you're starting to see a lot of these communities do, some of these materials that are not as valuable, you're seeing out in California and some of these other states, they're starting to eliminate from the recycle stream these products that are not as valuable as PET and can't be used as readily. So, PET will always have market. In fact, all the CPG companies, your Cokes and Pepsis of the world, they all have goals for including rPET or recycled PET for 2025 and 2030. They're all part of their sustainability programs, and this Bottle One really helps them because we can make up to 100%. We can put up to 100% rPET in that bottle.
Well, let's talk about. So you mentioned the other ways to create gallons was traditionally the HDPE, which you talked about the milk jugs, and we all familiar with that with the hollow handle. That's been traditional, but you also mentioned that if the people have tried to do PET1, but they've had to have an attachment. Let's talk about how that attachment slows down or change our manufacturing process, because we mentioned in our process, we were able to just blow and fill. If I have to add an attachment to my PET bottle, what does that do for my production?
Great question. Here is an edible oil package in PET. This is on the shelf. This is a great value brand from Walmart. So they have to have a pinch grip to open up the bottle. So you have to hold it with the pinch grip. You open this. Well, what happens? It pours out everywhere, right? Then you have this carrier, which 20% of the time is not there. Now to add this, you have to have a secondary process after the bottle has been blown, filled, and capped. And typically that's both automated and manual. I've been on some lines where this thing gets applied and then they got a person on the line that just does this. That's their job. They just push it down. And then it gets to the retail store or to the customer 20% of the time, that is still not there. One of the biggest issues though, Dave, is again, as we talk about sustainability, this PET bottle and this handle are two different materials. So it really impacts the recycle stream because this has to be taken off or
What is
handled
that
differently.
material in the blue?
That's a high density polyethylene
Oh,
material.
that's the same thing as the milk jug, the problem with the recycling, et cetera.
Yes. So you can't regrind the PET with high density polyethylene because it contaminates the stream.
I got you. So that's good. So it sounds like bottle one is really sort of changing things. Now, I've been to Chick-fil-A, right? And I've seen the Chick-fil-A like orange juice container. I think I've seen other clear bottles with a handle in it. Can you explain the difference between those clear bottles with a handle and this clear bottle with a handle? Because, it's like, I think I've seen a PET bottle with a handle before. How would you sort of justify those two things?
Clearly, I'm looking for one. I don't have one in the office. Sorry about that. So that you're correct, especially orange juice and Chick-fil-A. So that's what's called extruded PET. And so it's a different material. It's a very expensive material, much more expensive than the number one material that we use, traditional PET. It's a very weak material. So because it's so weak, you have to have a lot more material in it than you would with us. So for example, 120 ounce orange juice would have about 107 grams of material in it, where this bottle would have 30% less material in it because we have the strength extruded PET does not. The other thing that you get with extruded PET is it is so weak. If you drop it above like 1 foot, it would shatter. The other thing you have to have a corrugated box to protect it because it can't handle impacts or anything else. There's no durability to it. So it weighs more. You have to have a secondary package, much more expensive as a result than what we could do with our process here.
Got you. So is this bottle currently in commerce?
This bottle is making its ways to the shelf, and what we're hoping to do is to showcase StarWalker's industry's use of this package and really make this a case study for all.
Good. I'm looking forward to ordering some blow mold machines here. How long does it take me to get a blow mold machine, Brian? I need to order a blow mold machine so we can get our production going. How long does it take for me I just walk into your shop there and go, Brian, I need a blow mold machine. What do I have to do to get a blow mold machine so that I know you're going to sell me these preforms, you're going to ship them to me, right? But
Correct.
Now I need a blow mold machine so I can start my process. How long does that take to get all that stuff going?
Well, if you walked in off the street, and to one of the OEMs, the original equipment manufacturers, of course, they're going to quote you some long lead times, 16 to 20 weeks and stuff. But having worked very closely with you, I mean, we're anticipating your future need and we're planning accordingly. So we should be able to do much better than that.
Okay, so I get my bottle, I fill it, and maybe this might be Greg that comes back in, but let's talk about the filling and the filling process. So I have my bottle blown out, and now I'm going to fill it with juice or milk, or in our case, water. What does that look like in terms of the process to fill the bottle with water and cap it off and making sure that the water is ready to go?
Sure. So, obviously, to fill a bottle in a production center is no different than you filling a bottle at home, right? You have the water has to come out of the pipe and it's got to get put into the bottle. So you don't, again, another wheel type of filler, right? You're not going to wait here for one to get filled. You're not going to fill 6 at a time. You're going to do a wheel. So you got a big wheel and it's going to rotate like this. And so hose is going to come down. It's going to start filling, and it's going to fill all the way around until it's full. And then so you have different number of heads of fillers, right? You can fill any number. You could have massive heads, filling, over 50 at a time, and then you could have some that are less. But so you have a process where you're going to fill it around a wheel there, and then it's going to, after that is done, it's going to go into a capper, which is also another rotary kind of the other way, where it's going to get torqued and capped as part of that process also. And
Yeah,
so
you mean
it's
that
kind of a two-stepper.
I can't just walk down the conveyor line with my water hose and just fill them out. Just fill them in.
No, you got.
Because ironically, a lot of people think that bottled water is just, tap water and just somebody's just pouring the hose in it. Let's talk about reverse osmosis for a quick second and talk about the water that we take and the water that we put into the bottle, where it starts from and where it ends, the kind of things that you might see. And again, I see Greg might want to jump in here too, but can we talk a little bit about, taking the water, what we do to filter it and before it ends up in that bottle?
I assume Greg's
Yes.
handling that.
Go ahead,
Yes,
Greg.
we can. So, so normally what we would do is take that water, would run it through a carbon filtration system. The carbon removes things like chlorine and organics. And then we run it through what's called a reverse osmosis, which is a membrane, very, very, it's not really the traditional filter, but it's a membrane that allows very, very small particles to get through. So basically, water molecules get through, but not much else, not very, no solids or anything like that get through. And you have high pressure on one end, and you basically squeeze it through this membrane. And if the water quality is really bad, then you send it through it again. So there's a lot of testing that's done on the inlet side, and then that determines what you need on the outlet side for to get the outlet side, what kind of filtration systems we need.
And both purified, we know, comes from the municipal tap or the municipal inlet, but spring, comes in. Is the spring and the municipal water go through the same exact process?
So no, the regulations dictate that if you call it spring water, there's very little that you can do to it. You can't remove anything from it. You can remove organics, you can remove particulates, so any kind of dirt and sediment and anything like that you can remove. That's done with basic filtration, but you can't change its chemical process, what it's made out of. If it's spring water, that's otherwise you can't call it spring water. So spring water is, you don't use an RO through. Spring water, for it to be considered spring water, has to already be of a quality that is drinkable, and all you're really going to do is remove the particulate and organics.
Okay, great. Well, that was a good little synopsis, that we don't use the freaking water hose to fill our bottles, and we can't fill them at 8,000 per hour using that technique. So we have machinery to do that. Let's talk about the cap and the labeler. So I think, Brian, you mentioned that it gets capped. Greg, what about this labeler? Like, how does that all work?
So again, it comes out of the blow mold machines, it goes into the filler. There's a lot of handoffs, what's called a star wheel handoff. It looks like a gear on your bicycle, and just like the gear in the bicycle moves your chain along, your bottle goes into one of the sprocket gears, so to speak, and it moves around and hands off to another one, and it goes through the filler, gets filled, comes out of the filler. Typically it'll go through what's called a screw section, where it fits into the screw piece that moves the bottle down the line and orients it going into the filler, so that it's always got the handle in the right location. And then it's just typically a pressure sensitive label. So it's got glue on the back of it, and it's it's applied to the side of the bottle and moves on down the line into the case packer and shrink wrapper and everything else on the process line. But
Yeah, that's one of the most fascinating things that I've seen in the industry is the case wrapping. It used to be when you go to the store and you picked up a lot of things, you had the cardboard bottom and this plastic wrap. But now, Greg, it seems like they've been able to orientate the bottles in a way to actually use the exterior plastic in the actually functionality to lift the plastic. Can we talk about how that shrink wrap system works?
sure. So yeah, there's a large, pretty much all the major CPGs, all the major retail companies like Walmart, CPG being a consumer product group, but all of the companies, the Walmarts of the world, and Amazon and all these companies have made a huge push to get rid of what's called secondary packaging, right? And because it's a waste stream that not only builds up in the back of their warehouse, but it's also builds up in landfills and other places. So getting rid of secondary packaging is a huge plus for any of these companies. The way that your system will be set up is because the PET bottle has such strength within the bottle itself, we don't need to put it into a cardboard box in order to be able to stack it on top of each other and then ship it. So the bottles have the strength that are part of the bottle structure. And so therefore we can just shrink wrap around typically a 3-pack or a 4-pack and then put them on the pallets and let them then stack them 5 bottles high and have no adverse effect for the bottles that are on the bottom of the pallet. You couldn't do that with a high density bottle that the large bottled water right now is sold in for anything like in a gallon size. It's high density, much like your milk bottle. It's a very soft material. The whole process is different than the PET process. It's a one-step process. And that material has no top strength at all. So in the milk industry, they use plastic milk crate. We all have them in our basement storing stuff. And in a corrugate box, cardboard box. And both of those have a lot of inefficiencies and waste in the stream. So being able to get rid of that plastic wrap also is made out of PET, so it also can be put into the recycle stream.
So the wrap that comes around the positivity bottle, it comes around the gallons, that can also be treated as PET1 and recycled.
That's correct.
So that's where we're creating a full system, and they get put on a pallet. Now these pallets, how many gallons can we fit on one pallet?
Brian, you know that number?
I did not know that off the top of my head.
Well,
I would suspect it's somewhere, let's just say maybe 50 in a layer and 4 layers
5
high.
layers.
Yeah,
4 or 5 layers high.
It depends on the 3-pack, but you can get I believe 60 cases on
60 cases.
I believe so.
Per layer and 5 layers high. So 300 bottles.
Yeah. So that's the kind of pallets. We'll have those pallets done and ready to go and ship out of our place all day, every day. And we'll be making bottles this size as well as bottles like this size as well. So Greg and Brian, you guys have been fantastic. It's 12:50. We got 10 minutes left, maybe for some questions. You guys have any sort of follow-up points or things that you want to throw out there that maybe I didn't ask you that you said, Dave, you should know something else?
I just want to build 1 second on what Greg was saying about the strength and durability. One of the advantages of the bottle design, because it's integrated, this helps on the top load strength. This is like a 2-liter bottle has strength, but with this acts like an I-beam construction, and so it helps improve the top load strength even more. So the bottle one has an incredible amount of top load strength as a result.
And that's important in our industry for stacking, which makes things more efficient to ship. And that's very important because if you can't stack and storage, et cetera, then it makes it hard to deliver. So that's a good thing, the strength. I've watched you guys build this bottle and build this program and start to sell and now getting to distribution and bottling of this bottle. And it's very impressive. I'm glad we're a part of it. I'm glad, Bottle One and Intertech and their engineering skills is part of StarWalker Industries. I hold both of you in great regard. This has been a fantastic showing. I bet you there's only engineers watching this. everybody else is doing something else. But if you're into bottled water, if you're into engineering or manufacturing, our plan at the plant is to kind of have as about a see-through process as you can, so people can sort of be, pique their interest in coming into our plants. We want it to be welcoming for people to come in and be able to see the process. Some kid, 1 out of every 10 kids will be interested. The other 9 will be outside in the playground. So, you're always trying to tap into that one person that has that engineering mind. Shah, you have a question?
Yeah, we have a question. It says, how is the process distinguished from the process of other water distributors? So how is our bottling process different?
Well, it's the material that we're using, the PET1, and it's also the bottle we're using. So there's not a lot of people that's using this bottle. So when it comes to our proprietary technology, it's our license for Bottle One. The preforms they're going to sell to us in this bottle will be a lot different. So, bottling water is not rocket science, but you have to do it right. You have to do it with smart people. A lot of the private label, you can now, when you go out now and look at bottles, you'll be able to tell what kind of equipment they have. If you see a short bottle that's very thick with an HDPE cap on it, you'll know that, okay, they probably had older equipment. If you see a bottle that's smaller and faster and lighter and can crush, you'll know they probably use, you can look at the bottle now and tell what kind of equipment, if it's outdated or not. If you see someone selling you water and it comes in a cardboard bottom with wrap around it, you'll know that that's probably outdated technology. So the more you start to pay attention to things, you'll be able to see all of the bottled water. You usually see the 24 pack 500 milliliter that you see around town and at the gas stations, et cetera. Those are all being done by highly efficient bottling water systems with Niagara and Nestle, et cetera. By the way, Greg and Brian, you hear that Nestle has been banned from water production in California. I think we've been talking about this for a long time. It's coming. It's coming.
They haven't lost the suit, but yes.
Yeah, well, they haven't lost it, but it's bringing attention to them. They've had battles like this in Michigan and Florida, and people are realizing this is a resource we have to capture locally. So I think the timing on that is very interesting. But I think that when you start to look at it, you just need to produce enough water to feed your local community, and each community should have their own plant. So with you guys making it nice and efficient, and you guys showing us the basics on how we get through this, I'm sure there's years and years and years of engineering and design that goes into all of this, and you guys made it look so simple for a short amount of time. Shar, we have 5 minutes left. Any other questions that we could ask these gentlemen?
Can I add on that,
Yeah, go
Dave,
ahead.
for a sec? Because I think you sold yourself short there. I will tell you that for me, the really exciting part about what StarWalker's industry is doing and what differentiates them from their other distributors, which was the question, was the focus on the back end. You probably can't see it here, but David has front and center on this bottle 100% recyclable. And that's because the consumer doesn't necessarily know what that one at the bottom means. And so consumers are more inclined to buy something if they know it's recyclable. We're trying to do a lot of increase the learnings of the consumer out there and help them know what should be recycled and what has content in it. And so it's the back end where I think David is really doing some remarkable things to really differentiate himself from other guys that are just pushing plastic and water.
And we're going to pay for it too.
Didn't mean to interrupt.
No, it's right. We're gonna pay for it. We didn't get into this today, but the 25-cent incentives for a bottle like this to bring it back to our plant is built into the pricing. And because we're doing it locally and freight locally, water is very heavy. I think that one of the things you find out very quickly in this business, shipping water across the country through freight, et cetera, is just very heavy. So the sooner you can get it off this line and into people's living rooms and stores to be able to purchase, the better, because shipping it in across country or other states is very, very heavy and it gets expensive. And we started to see freight prices have gone up tremendously over the last 30 days even. and you mix that with people, upset about the resources being taken out of their state and shipped across the country, I think the storm is building for us to start to do things locally. And I'm going to incentivize people by offering a return. Greg is a big proponent of expanding our recycling to taking other PET1 bottles besides ours as well. And as we get more and more into our venture and get the better equipment, we'll be able to take the other bottles like the one Greg was displaying. I don't even know how you got that bottle in your office, Greg. You should have a positivity bottle. Think positive, drink positivity. That bottle you had in there. But anyway, I think I'm looking forward to expanding. I would love to take all PET1 bottles that are out there and start to add to ours, because actually there's value to it. If you watch this from the beginning, there's value. If you can collect that resin and you collect all that plastic together, you can actually sell it to the market who would want it, because everyone's demanding that you have recycled PET. I think we have a question. Mel, Spartan Green, no one asked you what team you rooted for. You just could have said Mel. Go ahead, Mel.
Dave, Mel wants to, says that you talked about outdated technology, and how long until the technology that we're using will be considered outdated, and what are we doing to make sure we're staying on the cutting edge?
Oh, well, you got to remember, these guys right here are already at the cutting edge. And if anything's going to change, it's got to go through Greg Kirshner. I mean, they're the ones who would track the changes. And Greg, you want to talk about that?
Sure, I'll address that real quickly. Like everything in technology, changes get made in leaps and bounds until at some point they just become very incremental. And for the most part, we're sort of in that incremental phase now. Just for instance, when 10 years ago, 15 years ago, the blow molders that we're talking about for some of these machines ran at about 1,200 bottles an hour per cavity, and nowadays they run at 2,400. Okay, the chances of them going to 3,600 is 0. Okay, so the chances of them going to 2,500 probably in the next 5 years, maybe. So, we're sort of at that, everything when it changes, it's sort of on this logarithmic curve, and everything changes much faster at the beginning, but we're definitely in the slowdown in terms of what's the technology is, and you guys are just getting into the marketplace, so you guys will have the latest and greatest. There's still a lot of companies that run machines that are 20 years old, and that was, I think, what David was alluding to is people that are continuing to maintain old machines and running old machines that are inefficient. There's a lot of reasons we can get into for them doing that. Almost all of them revolve around taxes.
Yeah, depreciation. So we have a 10-year business model and 10-year depreciation schedule on this equipment. So it's a plan 10 years. Obviously, we plan to upgrade as needed. We also plan to build other plants. And the idea behind all of this is if every city had 3 or 4 plants, you could start to do so much with the bottled water industry. You can practice on different materials. You can practice on using different preforms. So the idea is that once we get this into the common hands across the country, we can start to put in and have more innovation, because 32 million units is not a lot of units in the bottled water business. So you have the flexibility to sort of make some small things and try small things. And we want to be on the cutting edge of that, offering these solutions to different cities across the country.
Yeah,
okay.
One last quick thing. The other part that's very attractive about what David's put together is, the whole aspect about the shipping that he alluded to earlier, but having localized plants serving local customers and eliminating all that shipping, that's a huge factor. The number of trucks that you get off the road, the gallons of gasoline that you don't burn, the amount of carbon that you don't put into the air, it's a huge factor.
Thank you. Well, gentlemen, it's 1 o'clock. You know me, I start and end on time all the time, every time. This has been wonderful. If you have any sort of questions, you can sort of ship them over to me and I'll answer them the best. And remember, invest.starwalkerindustries.com. Our next session will probably be May 26th after we go public. We have huge announcements coming out. If you haven't already, start to put your money in, $100 minimum. And next thing you hear from me will be some video, or I'll be on some national TV show. And like, oh, that's Dave. So it's the time now to get in and tell your friends, tell your family members, invest in positivity, invest in StarWalker, what we're doing. We're trying to change the bottled water game. You see what kind of team I'm working with, the energy, the smarts. These guys are super smart, super smart. We scratched the surface. But until that time, you know, we're going to sign off here, and everybody have a fantastic week, a fantastic day. And remember, think positive, drink positivity. See you later.
Dave.
Thanks, everybody.
Bye.